Alright, this is lesson 8.2, which has to do with negative exponents. This is a rule you need to remember up here. If you have a negative exponent, it does not make the answer negative. Okay, it doesn't make the answer negative. What it does is it puts it on the opposite side of the fraction line, and then the exponent becomes positive. So let's write there. I'm going to add this to these notes. It puts it on the other side of the fraction line, and the exponent becomes positive. Okay? So that's what happens when you see a negative exponent. Again, remember, it does not make the answer negative or make a negative number. So we have 5 to the negative fourth times 5 to the third. When it's just a straight multiplication like this, you can still use the laws we learned in 8.1 and add these exponents. So you have 5 to the negative 4 plus 3, which is going to equal 5 to the negative 1. But I'd like you to write your answers without negative exponents, with all positive exponents. So what you'll do there is that becomes 1 over 5 to the first, or just 1/5, based on the rule we saw up there above at the start of the notes. Now looking at number 2 for an example, we have parentheses raised to an exponent. So remember, when we do that, we multiply. And so you have 2 to the negative sixth, and you should remember, I hope, that 2 to the sixth is 64. Negative means it goes on the other side of the fraction line, so it becomes 1 over 2 to the sixth. Exponent changes positive, which is 1 over 64. Always when you have numbers, go ahead and evaluate them and write them without the exponent. Alright, now looking at number 3, we're going to multiply across the top, and we can divide at the bottom. So we can do this a couple different ways, and I want to show you both ways to do it. According to the laws of exponents, this would be 8 to the negative 3 plus negative 5 over 8 to the negative 9, which would be 8 to the negative 8. Now we're subtracting for division, so it's minus negative 9, which becomes plus 9. And so our answer is 8 to the first, or just 8. Okay? That's one way you can do it, using just the straight laws of exponents. Now the way I really like to do it doing these kind of problems is like this. I make them all negative exponents first. So I draw my fraction line, and then I switch things around. 8 to the negative 3 will go on the bottom as 8 cubed. 8 to the fifth goes on the bottom is 8 to the negative fifth goes to the bottom is 8 to the positive fifth. And 8 to the ninth comes into the numerator, again goes to the opposite side of the fraction line, and the exponent becomes positive. So now we have 8 to the ninth over 8 to the eighth. Remember the rule, when you have a division problem, you subtract the exponents, and the answer goes on the side with the larger exponent. So 9 minus 8 is 1. 9 is bigger, so the answer is, again, 8 to the first. I mean, come out with the same answer. But this is the way you're going to see me work most of these problems. That's the way I like to work them. Number 4, 5 raised to the negative 3 power, 5/4 raised to the negative 3 power. So it's a division, all raised to the negative 3. So first we're going to rewrite that and evaluate, raise everything to the negative 3 power. Now the next step, change to positive exponents, which means 4 cubed goes in the numerator as 4 to the negative 3 goes in the numerator as 4 cubed. 5 to the negative 3 goes to the denominator as 5 cubed. And now we have 4 cubed is 4 times 4 is 16. 16 times 4 would be 64. 5 cubed is 125. I can't reduce that fraction. If you can, you need to reduce it, but I can't reduce that fraction, so that will be my answer. Okay. Now let's go on to our next page, work some of those examples. This one we're getting more complicated, but we're going to do the same process. We're going to take, we have 2 fractions. Okay, so we're going to write our fraction lines. Anything that's positive, we leave where it is. Anything with a negative exponent, we move to the other side. Now, one thing to remember is that these exponents only go with the variable that they're attached to. So here's x's, that x to the cubed is all that's attached to that with that exponent. Okay? And for example, this y cubed and y to the 5th and y to the negative 4th. The numbers are another piece altogether. The numbers 5, 8, 3, and 6 are separate. They're not raised to those exponents, and that's something that for some reason students tend to struggle with, and you need to remember. It's 5 times x to the negative 4th times y to the 3rd. 3 times x to the negative 3rd, y to the 5th. 8 times x to the 5th. 6 times y to the 4th. Okay, so those are separate, those are things that are multiplied together. So the 5 has a positive exponent, so it's going to stay in the numerator. X to the 4th is going to come into the denominator, and y cubed is going to stay in the numerator in this first fraction. And we have an 8 that's going to stay in the denominator, and x to the 5th, which is going to stay in the denominator. Now looking at the second fraction, let's just look at the numbers. 3 will stay and 6 will stay. X to the negative 3 comes into the denominator as x to the positive 3. Y to the 5th stays in the numerator. Y to the 4th goes up to the numerator and becomes y to the positive 4th. Again, if it's positive exponent, it stays where it is. Negative exponent goes to the other side of the fraction line. Now we can multiply across. We have 5 times 3, just multiply the numbers. 15. You add all the y's in the numerator, so we have y to the 9, 10, 11, 12. Okay. In the bottom, 8 times 6 is 48. X to the 9 plus 3, 12. Okay. Now, both of these will divide by 3, the numbers. So we have to reduce our fraction. 15 will become 5. 48 divided by 3 is 16. And we still have our y to the 12th, x to the 12th. And so that's the final answer. If these were x's and y's in both numerator and denominator, we would have to reduce the variables as well. Go ahead and divide those out. Now let's look at number 6. Again, we have 2 fractions, so we're going to draw our fraction lines. I'll make them plenty big so we have room to rewrite. Okay. Negative 2, that's a number, stays there. And the 6 stays in the bottom. X to the negative 6 will come into the denominator as x to the positive 6. x to the negative 3 goes to the numerator as x to the positive 3, and y to the 4th stays where it is. Now, we have 4/12. Those don't have exponents on them. X squared stays where it is. Y cubed goes to the denominator and becomes y cubed. Y to the negative 3 becomes y to the positive 3. Y to the negative 5th goes to the numerator and becomes y to the positive 5. Now, let's, within each fraction, simplify them as much as we can. Negative 2/6 is negative 1/3. X cubed over x to the 6th is going to leave us with an x to the 3rd in the denominator, and y to the 4th has nothing to simplify with, so it stays y to the 4th. 4/12 is positive 1/3. X squared there's no other x's in that fraction. And then y to the 5th over y cubed will divide to be y squared in the numerator. Now let's multiply these together. 1/3 times 1/3, one of them's negative, will be negative 1/9. Y to the 4th times x squared, y squared is going to be x squared, y to the 6th. And in the denominator we have x cubed. Since we have x's in the numerator and the denominator, we're going to have to simplify those, or reduce that fraction. So we have negative 1/9. X squared over x cubed is going to leave us with an x in the denominator and y to the 6th in the numerator. Okay. Now let's look at number 7. This squared here has to be evaluated before we do anything else. So we can go ahead and let's just write our first fraction just like it is. We won't do anything to it yet. Okay. Parentheses raised to a power, we've got to multiply those. So we multiply everything. We have x to the 2 times negative 2 becomes negative 4. Y to the negative 1 times negative 2 becomes y squared. Z to the first times negative 2 becomes z to the negative 2. And z cubed in the denominator becomes z to the negative 6th power. Okay. Now let's swap places with everything. So let's look. We will have x to the negative 3 come into the numerator. X squared go to the denominator. Y cubed stays where it is. Y squared stays where it is on the bottom. And z to the negative 1 goes on the bottom as z to the first. Okay, that's the first fraction. The second one, x to the negative 4 goes down, becomes x to the positive 4. Y squared stays where it is. Z to the negative 2 becomes z squared in the denominator. And z to the negative 6 becomes z to the 6th in the numerator. Now we have to multiply straight across. So when we do that, we have x cubed, y to the 5th, that's where the 3 plus 2, and z to the 6th. We have in the denominator x to the 6th, y squared, and z to the 3rd. Okay? Now we're ready to do our final simplification. Looking at our x's, 6 minus 3 is 3, and so the bigger, the 6 is on the bottom, so it's going to be x cubed in the denominator. Looking at our y's, y to the 5 minus 2 is 3. The 5 is the largest exponent, so it's y cubed in the numerator. And z to the 6 minus 3 is z cubed, and that will also be in the numerator because 6 is bigger than 3. And so that would be our final answer for that last example. That finishes up 8-2. Hopefully that'll help you with your negative exponents.